Welcome to today's webinar. I'm Tim Stewart from Visual Decisions. I've spent a lot of time over the years helping companies get data from the shop floor and use that to improve their operations. And with me today, I've got Frank Costa from Sandalwood. I'll give him a minute to introduce himself in just a minute. And today we're going to talk about companies that have their data stuck in different silos and where you can't see the full picture of what's going on the shop floor and the rest of the business. Frank, we've run into this a lot over the years. Can you share some information about yourself and the topic?
Sure. My name is Frank Costa. I'm a manager here at Sandalwood Systems Integration Group. Been doing this work for seems like forever, Tim. It's 20. I did the math. I started in '98, so let's just say over 25 years. Started out at a machine builder as a controls engineer, and sort of moved up. Worked at the big three, and then came over at Sandalwood. So I've worked actually on both sides of the fence on here, on as a producer of data and also as a consumer. Yeah. That's me, and this issue has come up time and time and time again. Different systems, they don't talk to each other, and then you're scrambling at the end of the day trying to make sense of what actually happened and why.
I'm going to go out on a limb here. I've never once been to a company that didn't have at least some data silo issue. How about you?
Yeah, I mean, the easiest one is always between, maybe the SCADA system telling you what's happening on the shop floor, on the ground, versus some sort of scheduling or ERP system. They just, the one informs the other, but to get a full picture of what's going on, they should be talking to each other. That's just a classic view. You can go, quality systems, just the whole thing. Standard
maintenance, supply chain planning,
all of it, right? Especially on the legacy side.
Yeah, I mean, I remember back in the early 2000s having conversations about the IT and OT divide, and I was at a conference earlier this year where they were talking about solving the IT OT divide.
Yeah, no, I know. Try to go through and contain 21,000 engines where 3 of them might have an out of conforming front cover, and try to find the data. This is going back in the early 2000s. And again, the systems don't talk to each other. So yeah, it was a lot of work, work going out to the B&A plant to go through and sift through all those issues to find the 3 that caused the problem.
Yep. All right. Why don't you tell me a little bit about why this matters so much?
Sure. So, as we discussed, right, there's so many different problems that happen when you have the data silos. Some of it, the bottom line, it's inefficiency and increases costs. So siloed data often forces your team to rely on some sort of manual process or man-in-the-middle process to gather and reconcile information. And just doing that work leads to a lot of wasted time and resources. And the lack of that real-time visibility to operations can cause and does cause delays in actually detecting and responding to the issue. Another one is, poor decision makings.
Yeah.
Without a unified view, manufacturers struggle to make actual data-driven decisions. So isolated data sort of prevents predictive analytics. And in today's world, everyone wants to go AI-driven optimization. You just can't do that sort of work when you have these siloed data.
I mean, most extreme example I've come across was a company that I worked with back in probably about 10 years ago now. And they wanted me to create a quality dashboard for them. So I asked them where the data was. And the IT people told me all the quality data is in SAP. And after I stopped laughing, I was like, no, really, where's all the quality data? And they were kind of hurt, and they said it's all in SAP.
Yeah, I know.
And
It's
so in the end, I found across 9 plants, I found 57 different systems with quality data in it.
oh my God. And then it was your job to dashboard them, right?
And it was my job to dashboard it. And it impacted their decision making because they had no idea how to create a unified view. All the things that were ending up in warranty, just as an example, they would look for information about what happened in production. They wouldn't be able to find it because nobody knew about all the systems, let alone about the data in those systems. So yeah, it can be a huge impact on decision making.
Yeah. And I'm going to just to go off of it, I'm going to go out on a limb. Out of those 57 or 56, different systems, how many were structured in the same way? How many contained the same data? Did they at least use the same date time format if they were capturing that? I mean,
some of them were organized in the same plant. Some of them were organized around departments, and some of them were organized around value streams. The machines were all named differently. The products were named differently, and it was a mess. Oh, and then we found out that in different shifts within the laboratory information management system, the guy in the first shift would put in decimals as 0.45. The guy in the second shift would put it in as 45%.
oh my God. Yeah, that none of this surprises me, but I always get a chuckle. I mean, listen, that's literally one of the other issues, right? It's limited collaboration, innovation. Different departments, even the same departments, right? They operate or could operate in isolation, and that just reduces that opportunity for sort of that cross-functional problem solving that you were alluding to.
Yeah.
It's always seems to be an issue with these older systems, especially.
And as a system integrator, sorry.
That's why, depending on who's watching, right? As a system integrator, yeah, I was just going to go over there. As a system integrator, we do play a key role in sort of breaking down those silos by implementing systems like an MES, an ERP, a SCADA. They are different systems, but in today's world with today's technologies, it behooves us to go to our customers and say, here are your different systems, but they got to talk to each other. There has to be a mechanism for data standardization and interoperability. It's just crucial. And again, as we're moving, you can call it, IoT 4 or whatever buzzword you want to use, 4 or 5. AI has to, in the future, it has to be able to ingest this data. These data silos are just a brick wall to that.
Yep. So how do we end up in this mess? What have you seen out there that creates these problems in the first place?
Well, I'm just going to jump over my next slide, right? And it has to do, we're in 2025. There is a revolution in the early aughts where we started bringing in a ton of different data, which was great, but they were all in these proprietary systems. The information was very much targeted to specific users. I'm just talking about the systems. I'm not talking about the gazillion Excel sheets that are running out there, actually trying to run and interpret the data, right? So it built into that first generation, let's call them, of systems. They're siloed. There's a lot of it is proprietary, and that includes not just the methods to collect data, but also the methods to store it. So these systems were not designed for interoperability. In today's world, modern systems, even server-based systems, I'm not talking scale, like a ERP or MES, they have APIs. You talked about SAP. There are APIs in there that gather to at least interrogate the data, which just don't exist in those legacy systems.
Yeah. On the slide, you have a good example of another way, right? Different departments using different systems and different purposes and so forth.
Yeah, and that's just, again, not just a proprietary nature, but how the data is structured, how it's saved.
Yeah.
And again, the different systems, they might work great for the specific application that you're using it for. But when you want to start combining that data, they just don't act as a cohesive unit. And that's because, I mean, you had a perfect example, percentage versus decimal, or what is the precision of the value you're collecting? Does the system allow for a finer or um, more granular um, data acquisition profile, let's call
Right.
it? There is just a lack of standardization in data collection and storage. And when I say data collection, I'm not just talking about the machine, but it's also what's coming out of the MES. What does your build recipe look like? What does your order, right, look like? We're still, a lot of places are still using EDI, which is great. It functions, but it's again, it doesn't cascade down to other systems that could also utilize that data.
And you know me, I'm a lean guy. And something else that I've seen is, all the manual generated data, whether it's tick sheets or paste boards or whatever, and then people coming in and, typing that information into someplace, that inevitably ends up as siloed information.
For sure. And it's, best case scenario, you might be sophisticated enough to push it to maybe an access database. You might share it on a shared drive, which at least you have one common area, but that's a best case scenario. And again, they don't function properly with how we want to use the data. You shouldn't have to worry about if an operator comes in or a supervisor comes in and wants to pick up, hey, what happened last shift or 2 shifts ago, so I know what my maintenance has to do. Do I have the latest and greatest? Is this correct? Is there a different version? Like all those sorts of questions. And it does lead, again, we use Excel because it's there and it's easy. So when you're looking at front ends, when we go through and design front ends for customers, it's always with an eye who is the primary consumer, but it's primary, secondary, and tertiary, right? And that third might be not interested in how it gets in, but
The outputs
actually
of
collecting the data. Yeah, interfacing with it. Where the first two might be someone who does the input, and that secondary is someone looks at it. So you're thinking a supervisor or a production manager along those lines, or a quality engineer and director of quality, as an example.
Yeah.
Yeah.
Something else that I think contributes to this is you end up with these turf wars. Everyone will say, yes, it's a problem that our data is in all these different systems, but I'm not going to give mine up. Everyone else has to change what they're doing. What have you seen there?
Oh, I mean, yes, it's resistance to change. And yes, the ownership, I've seen that it happens at small firms and it happens at large Fortune 100 companies. And I've seen it. People recognize the issue of having data contained in one location, but you have people that have a vested interest in keeping it that way because that's their job. I'm here to manage this piece of data, even though we want to talk to the other to something else, and it makes sense, and it'll help reduce costs, increase productivity, and whatnot. I'm keeping my pie, and you change what you're doing. And you know what happens? There's a man in the middle. There's a whole industry that creates, we call them microservices now, right? Little programs that run on the side that do some sort of manual or it's actually some of it is automated reconciliation, which works until something changes somewhere. I'm adding new equipment maybe on my SCADA, and then it breaks that automation in the middle that's talking to the MES, because you have to do it not at one spot. You have to fix it at 2 or 3 or 4 different spots. Every single one of those man in the middle type interventions is a point of error, of inefficiency. Just it's wrong. Why do we do things 3, 4, 5 times? Do it right, do it once, and then move on.
Yeah, like I said, I'm a lean guy. Rework drives me nuts. So let's talk about some of the real world impacts of the data silos. I gave the example of the company with 57 different quality systems, and the lack of visibility that they had, the inability to trace warranty issues back into the plants and so forth. What are some of the things that you've seen?
I mean, that's a classic, right? Just the limited operational visibility. I've got in my notes, I have like 9 or 10 different things. I put a couple of them up here, but it is that when we talk about visibility, it's not just at a production level, but it's also at a decision-making level. We use these systems to run everyday manufacturing process. Doesn't matter if you're a discrete manufacturer or process manufacturer, it doesn't matter. But the amount of data that we're collecting shouldn't just sit there, right? You need to be able to use what's happening and what happened to help make informed decision on what you want to do moving forward. And without the interconnectivity, even just to that example of quality, I've got a quality issue. Where was it built? When was it built? What was happening to the machine? What was happening to the tooling on the machine? You might be tracking it as an incidence. You might not have the granularity at the SCADA level to be bringing in maybe a serialized information, because SCADA in the olden days, right? It's might be changed a little bit, is all about the machine, not what the machine is doing.
Right.
Which is an antiquated view. Yes, you want to know what the machine is doing, but you got to tie it to the process, what's being done to the part, and tracking that all the way through. So when there are issues, you're not tracking down 21,000 engines for 3 front covers. You're going through to 10, and you should be able to go over and locate where those 10 are in the next process to contain them.
Right.
That's a huge cost efficiency, huge time. It saves a ton of time, and it keeps your end customer safe. I'm using engines. That's where I grew up.
Yeah.
Going through in powertrain, right? But it doesn't matter if it's an engine or, geez, now I've lost the track where we're going. But the product doesn't matter, right? You might be making cutlery.
Yeah.
Does it matter that you get 3 tines on your fork instead of 4? It would matter to me as a consumer.
Yeah, in that case, you're not looking for serialized information on something that's high volume, but you're looking for a time slice, right? You're looking for,
correct.
I want to see anything that was made between 10:15 and 10:30, because that's when I was having those issues on the machine.
Right, and that's part of when these systems to break down those silos. What are those connection points? As you said, in a process, you don't have serialization, right? In a process type environment, you might have lot, you might have recipe, but you have to work order. Perfect. You've got to understand what you want to key off of. So it could be time is sloppy, but it might be the only way to go through and do it. At the very least, you narrow your search parameters from this big to here, right? And again, what happened at the machine? What was done at the machine? What was done at the product? The quality issues that came up. When we're talking about machines, there's all kinds of metrics around time. What's the takt time? What was the cycle time? The deviations in something as much as time that it took. When you're talking about battery manufacturing, it's chemistry. Reactions and things happen based on time. You want to make sure you're holding it in cold storage for 8 hours, not 9 and not 7. It's got to be 8 with a plus or minus 10. Like those kinds of that kind of information, it's shared across multiple systems.
I mean, even something like assembly. If a cycle takes too long, there's a good chance that something abnormal happened during that process.
Sure.
And so, that's a potential quality issue. Got to keep us moving a little bit here.
Sure.
Let's talk about some of the key strategies when we get to, how do we avoid this issue, or how do we mitigate it and, fix the issue?
I mean, mitigation, full mitigation, right? It can be expensive and it could be timely, right? So I did take a chance to sort of break down some strategies to breaking down those data silos, right? It's you want to identify the opportunities in the existing systems. Hey, inside my department, I am running 4 different Excel sheets and an FIS system. Where can I commonize? Can I get down to one? Are the older unsupported systems creating unnecessary barriers? Can data collection be streamlined? That's the biggest one, to remove that redundancy. So identifying where you're at, and I talked to another webinar, is very important, with an eye, again, of scaling it down.
Right.
The next two are functional. And people may have heard of UNS and CDM. Just quickly, implementing a unified namespace for real-time data integration. If those of you don't know, a unified namespace is it's a centralized data architecture where industrial data is organized into a single structured hierarchy. And it utilizes a pub/sub architecture. Loves using MQTT, but you can use OPC-UA, Sparkplug-B, which utilizes MQTT as well. But what it does is standardizes the transport data. And it helps create that single source of truth for the systems that are using it. The big one, though, it eliminates custom point-to-point configurations or integrations, because if you implement, let's say, a UNS with MQTT, adding nodes, adding data to those nodes, they self-subscribe. So you're only doing that very edge connectivity, and then all the data just starts flowing upwards.
Okay.
Yeah, the third one, and they go in conjunction, is planning or creating a custom or a common data model. So it's similar, but I wouldn't say similar. It's different than a UNS, but they're complementary. So a CDM is just a standardized structured framework that defines that data consistency, that formats, relationships, and whatnot.
So going back to the company that had 57 different quality systems, the common data model would be how I actually store and manage the data in a common way across those different systems. The unified namespace would be how I'm collecting the data in the first place.
Think of it as a highway system. The UNS is the roads, right? It's connecting the data, it's doing the transport. On a highway, you want the roads. You need signage and rules of the roads. That's what the CDM is.
Okay.
If that makes sense.
Yep.
So there's a common data transport and a structure to it so that how the data can be understood. If you can only do one, I would highly suggest going the UNS route, because you can build on it as your transformation matures. It's easy to tag on metadata that can be consumed or populate a common data model.
Okay.
The fourth point is just going over there, right? Trying to speed things up. Use real-time data collection, and when we're not just talking machine data, we're talking quality data, keeping that EDI to ERP system, MES, that connection live and as up to date as possible. To that point, use your MES and ERP systems. Most, if not all, manufacturers have some version of this. That data is super important and informs what happens on the floor. Create that connectivity so the data flows seamlessly down the floor, if that makes sense. So connect your MES to the SCADA for machine data for real-time process tracking, connect the MES to the ERP for improved scheduling, material tracking, and cost analysis. Yeah, and the next one is, depending how big you are, the cost and whatnot, figure out if you want an on-prem or cloud based system. Cloud, cloud is super scalable. It's easy to access by AI driven analytics. It does require strong cybersecurity measures, and there is a cost for taking all that IT footprint and moving up to the cloud.
Right.
The on-prem, it gives you a lot more control and security over your data, lower latency for real-time reporting, but scalability is on you. You're going to have to be able to manage all the requirements on that end.
Right. And might require additional in-house IT people and so forth.
For sure, right? It's a cost.
Yeah. And I mean, when we look at that, there are various industries that have requirements about, where data is stored and transported and all those wonderful things as well.
Yeah, for sure. I do want to, if I could just, I'll flip over to just the other slide so you can kind of see when I was talking about the CDM, the differences.
Yeah.
Where I'm looking at common data model, they're under headings. It's a schema. It's sort of a schema where your UNS is more an ordered and structured format for adding. In this case, this is a production line, but adding to it, and again, using that MQTT engine, SparkWeb is great at it. Everything as you add, it self-subscribes and starts spitting out that data. And just to your point, right? They work together. UNS organizes the transport, and CDM defines that, defines what the data means. UNS is hierarchical and event-driven, so great for real-time data, while the CDM is structure and schema-driven, which is great for analytics, reporting, and again, AI.
Yep.
So.
Yeah, and if you want to get to the point where you're doing AI, I don't think it can be overstated how important it is to have that contextualized, structured data that's accessible and consistent.
Agreed. I know we're just checking on time. We're very limited. I'm just going to just very quickly bring you over. This is usually what the traditional manufacturing landscape looks like.
Yep.
You have different pieces of data. Each one has its own system, goes somewhere proprietary, stored in different databases, and they have their own interface. So I'm going to actually going through and implementing both UNS and instantiating a CDM. So just very quickly, the same data, you want to use maybe a common platform that's flexible enough to ingest the various types of data protocols that you're coming in, seeing on this side. I hope you can see my mouse.
Yep.
And that ingestion would be based on a UNS structure, so hierarchical. But once that data is collected at this common layer, you parse and transform it to match in, to sort of adhere to your CDM, and then publish it out on the back end. In this example, I have it as a data lake where I have process data and whatnot. ERP would be connecting over an API, and again, holding the information in the same area or applying that CDM to your ERP. It might be in a separate area. Front ends would just be looking at the specific data they want. But because they're together, they're organized using a CDM, the information automatically self-subscribed using the UNS. You can cross-pollinate the information. This is an example. I always, you could do this with a ThingWorks and Ignition. They have the ability to consume multiple output to that MQTT channel and act as that, especially Ignition, especially with that with their Python engine. You can create the rules to set up your CDM. If you don't want to go that far, you can still use in this case, I've got ignition, Node-RED, device-wise, and high byte. Consuming different information could be from different systems, but they all have that ability to establish a UNS and instantiate the CDM model. And again, publish it out. It doesn't have to go to a data lake. They can be separate, but the CDM makes the data accessible all the way across. And I know we're at time.
Yeah.
I wanted to show this. Our inspector from CirrusLink, it was a great talk that he gave at ICX last year. Poor planning, you don't plan for it, you're not getting a data lake, you're getting a data swamp of just a lot of messed up data. Take the time, think about what you want to do. Again, if you don't want to go full CDM, start using that UNS to help structure that data so that it can be consumable across your entire system chain.
Let's see. Yeah, we are a minute past our half-hour target here. Any closing thoughts?
Their siloed data, you might not feel it now, but especially the changing landscape, you have to start using the data you have.
Yeah.
Everyone's collected it. Start using it. That's it.
Yeah, that's usually the first question I ask people when they talk about buying a new system to collect more data. The first question I usually ask them is, how well do you use the data that you have today? And usually the answer is not well. And so I'm like, okay, before you pile more information into the pile that you're already not using well, maybe think about how to structure that data more effectively, how to get it into a place where people can utilize it in their daily jobs much more effectively before you start piling more in there.
Sort of like if you've got an FMEA, let's tie it to the actual machine and make it accessible.
Yeah.
I know it's one of your favorite ones, Tim.
Yeah. Value stream map too.
There it is.
All right. Well, thank you very much, Frank, for joining us. If you want to put up your contact information, highly recommend anybody that's listening, give Frank a call. Contact information is there on your screen. For me, I'm just tim@visualdecisions.com. You can email me as well. And thank you for joining us, and look forward to talking again sometime, Frank.
Same here, Tim. Always a pleasure, bud.
All right. Bye.
Bye.